Here's integrated 3. It's problem 2-60. It says match each expression on the left with its equivalent expression on the right. Assume that all variables represent positive values. Be sure to justify how you know each pair is equivalent. So if I assume that all the variables have positive values, I don't have to put those the absolute value bars on them. So I'm going to justify my answers just by, even though I could probably make some matches just by inspecting these, since I have to justify how I know each one's equivalent, I'm going to go ahead and just fully work out each of these until they make a match. So let's see this one. So I like to break them down into pieces, perfect squares. So this is 4, like the square root 4 is 2 squared, right? I hope this makes sense when I do it this way. So 2 squared, well, I'll do the next one a different way. But to me, since this little index right here is a square, it's like now I can just bring out a 2, an x, and a y squared. So this is just going to be 2xy squared. So that's one way of doing it, is making all the exponents on the inside 2's so that they kind of cancel out with the index here. Another way of doing it is to show how you break them down, like break them down into perfect roots. So I know that 8, I can write it as root 4 times root 2 times root x squared. Remember, those match, so that's going to cancel out and be an x. And then I'm going to do them all a different way. I hope that doesn't make it worse. So what's the square root of 4? It's just 2, right? So I'm just going to write that down as a 2. And then doesn't this one cancels out, so that's going to be an x. And then the only thing I have left underneath the radical sign is the 2 and the y. So I'm going to write, I'll match them up at the end. I don't know if they're already matching. I'm going to just keep going. So this one, square root 4 is a perfect square, so I can take that out as a 2. Square root of x squared is just x. And then the only thing that got trapped inside the square root sign is the y. So you just leave it like that. So basically, perfect squares can come out. They come out from under the radical sign. So we know what the square root of 16 is. It's 4. So now this x isn't a square, so it can't come out of the radical sign because it's not a perfect square. Y squared is a perfect square. So if I square root the perfect square, then the y can come out from under the radical sign, but the x it's still trapped inside there. So it's kind of like that. And then, so here's the 8. We've broken down an 8 before. We know 8 is 4 times 2. So I can show it though. I'm showing these all different. So this 4 is just a perfect square root of 4. So that's going to be 2. These 2 are not perfect squares, so they have to stay inside the radical. This one is a perfect square. Y squared is a perfect square. So we're going to let that one come out of the radical as y. And then we're stuck with a 2x inside. And then we can just go through and try to match. So this a is 2xy squared. So I think that goes with number 3. and then and then let's cross that off. And then 2x root 2y. That's number 4. And then 2x, sorry, 2x root y. That's number 1. And then 4y root x. That's number 5. And then 2y root 2x. That's number 2.